Greetings, students. Thank you for joining us for our class sessions for Mission to Mars. The point of today's lesson? NASA needs you. That's right, NASA and Jet Propulsion Laboratory needs you, your energy, and ideas and enthusiasm. We're looking for you to be in the pipeline to continue the work of getting us to Mars and other planets in your future career. In recent weeks, you may have heard exciting news about outer space. JPL's probe, Juno, is set to be the first spacecraft to land on the surface of Jupiter this July 4th, and we are hoping to gather some important information about that giant planet. 40 years ago, on July 20th, 1976, the Viking 1 space probe made the first successful landing on Mars, and in the years since then, Jet Propulsion Laboratory has sent many probes to see if Mars could support life in its past or even in its future, in hopes we might send humans to explore in person. One troubling matter, the length of the mission. 50 years ago, a mission to Mars would have taken 2 years, but now is estimated to take only 6 months. Improvements in technology and spacecraft design could reduce that time even further. Think how that could help. Even 6 months is a very long time for humans to be cooped up in a small spaceship, but solving this problem will take work in designing more efficient spacecraft. What we want to need are a new and continuing influx of people who can pump some new energy and ideas into the mix. We want to start with you and get you to think about this. And one day, you might even be the hero who will design the better and faster spacecraft. Your mission, if you decide to accept it, is to design and build a model rocket and to launch it. How? First, let's discuss the logistics of launching a rocket with a payload of humans and getting it off the ground and to its destination. First, we need to send cargo, humans. But what else do humans need for a long journey? Can you name some? Food, water, oxygen, tools, items for entertainment, and more. Humans traveling to Mars will need to take some supplies because they won't be able to simply shop at a local store for anything. That requires a fairly big cargo area, also referred to as a payload, and it follows that a big payload will weigh more. Therefore, we'll need bigger, more powerful, and faster propulsion systems to launch them from Earth into outer space. In the past, large rockets were used. The first manned rocket into space was a Mercury Redstone, which was succeeded by the Atlas launch vehicle, which was replaced by the Saturn V rocket for the Apollo moon landing program. These rockets were powered by liquid propellant. Years later, the Space Shuttle program used the Aerojet Rocketdyne main engine with 2 solid-fuel rocket boosters helping with the initial launch. This is worth noting because solid rocket engines are used for some model rockets, although we won't be using them for today's models. Propellant rocket fuel is only one element. Design is another. Aerospace engineers have worked to make designs sleeker, faster, and more efficient for airplanes and spacecraft. They have to understand the principles of lift plus thrust and overcoming resistance of wind and gravity. Your turn. Now it is your turn to be an engineer. You won't be using high-tech equipment. Your raw materials will be more simple, but that is to allow you creativity and to get you to think outside of normal parameters. With simple materials, you will figure out how to make your rocket launch successfully and reach its destination with a payload of passengers. Not alive. Your teachers here today will show you. I am sorry I could not be with you today, but that is why I made this video. I hope to see you in person next time. I'm Dana Rose Crystal. Good luck.